You are standing at a control valve on the unit. The operator changes a set point on the DCS. 100 milliseconds later, the valve stem moves. No one touched the valve. In this video, we follow that signal from the pressure transmitter in the field through the junction box and marshalling cabinet into the Yokogawa Centum VPFCS, through the PID calculation, and back out to the control valve actuator. The pressure transmitter is a converter. Process pressure pushes on a sensing diaphragm. Electronics measure that deflection and output a current signal. 4 milliamps at the bottom of the range, 20 milliamps at the top, proportional in between. If the range is 0 to 10 bar, 12 milliamps means 5 bar, exactly halfway. The transmitter runs on loop power from the DCS. There is no separate supply at the instrument. 24 volts DC leaves the AI card in the Centum VPFCS, travels through the marshalling cabinet, the junction box, and the field cable to the transmitter. The transmitter uses that energy to operate, and it controls how much current flows back. The same two wires carry both power and signal. From the transmitter, the cable runs to the junction box in the field. Instruments home run to numbered terminals inside. A multi-pair cable runs back to the marshalling cabinet. In the marshalling cabinet, individual pairs connect to terminal blocks. Those terminals wire directly to the analog input card in the Centum VPFCS. The analog input card measures the loop current. An analog to digital converter samples the current and turns it into a number. 12 milliamps, 50% of range, becomes approximately 30,000 counts in a 16-bit register. That number sits in the I/O memory of the FCS, ready for the CPU to read on the next scan. This is what happens inside the Centum VP that you cannot see. Every 100 milliseconds, the CPU reads the analog input register as the process variable. It compares that value to the operator set point. The error drives the PID calculation, proportional, integral, and derivative. The result, a percentage from 0 to 100, is written to the analog output register, 60 times per minute, invisibly, inside the controller. The analog output card reads the PID output register. It converts that percentage back into a 4 to 20 milliamp signal. 70% output becomes 15.2 milliamps. That current leaves the AO card, travels back through the marshalling cabinet, the junction box, and the field cable, and arrives at the IP converter on the control valve. The IP converter receives the milliamp signal and converts it to a pneumatic signal. 4 milliamps gives 3 psi. 20 milliamps gives 15 psi. At 15.2 milliamps, approximately 10 psi reaches the actuator. The actuator converts that air pressure into force on the valve stem. The stem moves, the plug lifts, and the flow changes to match what the operator asked for. Every automatic control action follows this same chain. Transmitter measures the process. Signal travels through junction box and marshalling to the FCS. The FCS runs the PID calculation every 100 milliseconds. Output travels back through marshalling to the IP converter. Air pressure moves the actuator and the valve. One closed loop, fully automatic. That is how Yokogawa Centum VP controls your process.